So in a previous lecture, we talked about electric circuits, and I want to come back to them because I want to talk a little bit more about them. So we already know that this is a closed path that electrons or current can flow through. And we also talked about how you can make gaps in the circuit, so you can make breaks in the circuit to stop or allow flow. And these are usually switches like wall switches, or you can make, put switches on like a light or something like that. And most of our circuits are going to have more than one device that has electricity receiving are coming to it. So like our household circuits usually have multiple like ceiling lights on it, or it'll have multiple outlets on it. And some of them will actually have a combination. A couple of them in my house have a couple of ceiling lights and a couple of wall outlets. So that way you can have multiple things running on the same circuit. So the circuits that you have in your home and circuits that you've got, for example, at the college, in other businesses and industry are going to be AC, because the power that's coming to those circuits is being generated by a generator from a power plant. And so it's coming in as AC current, or I'm sorry, as AC or alternating current. And most of our portable circuits are DC. So for example, a laptop or a cell phone is a direct current circuit because it's got a battery on it. So anything that's running on battery is going to be a DC circuit. You can also connect circuits in a series or parallel circuits, or a combination of them. And so that's what I want to talk a little bit about here, is what is a series circuit and what is a parallel circuit, and how can you put those together? How do they show up in places like our homes and businesses? So we're going to look first at a series circuit. Let's see. If I put me here, that'll probably be the best place. So series circuit is just a single pathway for electron flow. So you can see up here, this looks very similar to the circuit drawing that we saw before. We've got a battery, we've got it connected to our two terminals, positive and negative. The electron current, the electron flow is going to go through the wires to the three lights and back to the battery. So only one way for the electrons to go. If we put a break anywhere in that circuit, the electrons are going to stop flowing. And so you can see in the picture down here, that's what they've done. This is the switch. The switch is open, which means there's no electron flow and none of the light bulbs are lit up. This is actually a downside to series circuits, because you make a break in a series circuit anywhere and it stops electron flow to everything that's connected in the series circuit. The other thing that happens in a series circuit, and that can be an upside or a downside depending on what you want to use the series circuit for, the resistance of the devices that are on the circuit add together. So remember, the resistance is going to slow down the current. It won't necessarily change the voltage, but it's going to slow down the current because you're increasing the resistance, because you're adding more and more things to have that circuit do work on. And it adds together, so more devices equals less current. So here you've got 3 light bulbs. If you only had 1 light bulb on this circuit, it would be very bright. But with the 3 light bulbs on this circuit, the light bulbs are much dimmer because all 3 of them have to share the electron flow that's coming from the battery. And so that's one of the things with series circuits, is when you're in a series circuit, the resistance increases the more devices or voltage drops you put on that circuit. So that's one of the big disadvantages. As you put more devices on a series circuit, you get a drop in the current available to each of the devices that are there. And if you break the circuit anywhere, it stops the current, it stops the electron flow. So think about Christmas lights. If any of you have ever had to deal with strings of Christmas lights that you plug them in and they're not turning on, or part of them aren't turning on, you have to play the game of find the empty light socket or find the bad light. And that's because that has caused a break in the circuit, and most of our Christmas lights are strung in series circuits, so that all of the lights are equal brightness, but that gives us the problem of if one of them goes out, all of them in that part of the string goes out. So there you can see the formula. This just shows you for resistance. So the resistance of the circuit is equal to each of the resistances of the things that are plugged into that circuit. So you add the resistance of each of these lamps, and that gives you the total resistance of the circuit. So it just keeps increasing. So the other type of circuit that we can have is what we call a parallel circuit. And these ones are a little different. As you can see, it sets up a little bit differently. Here you get a branched pathway for the electrons. So instead of just one big loop, you get multiple loops. And so you can see you've got the same sort of setup. You've got your voltage source, you've got your battery, and you've got your electrons flowing. But at one point, they branch off so the electrons can go in any of those directions and flow through the light bulbs and then back connected together and go to the battery. And the advantage to these parallel circuits is because there are branches. If you break one pathway, it doesn't interrupt the other paths. So you can see up here, they have an open switch just like we saw in the series circuit, and that light bulb is out, but the other two light bulbs are still lit up. And so what's going on here is it's kind of like if you think about the lines at a grocery store. All right. If you have a series circuit, the one that we just talked about, series circuit is they only have one cashier checking everybody out. Everybody has to get in the line, right? And if that cashier goes on break, you all have to sit there and wait. Okay, so that's like what a series circuit would be. Everybody just waits. Then the cashier comes back. That would be the switch turning back on, and then you can start going again. Parallel circuits are like the lines at the grocery store, but there are multiple lines open. And so everybody can go to the different lines. If one of the lines has a cashier that goes on break, that's okay, because you can go to one of these other lines. All right, so the electrons can go to multiple lines. And the thing is this is a little different. So as the number of branches increase, the resistance goes down. This is because there's more and more pathways available for those electrons. Think about again at the grocery store. There are more and more lines open. There's less and less chance of people, getting upset or angry about having to wait. And so, there's more and more places for you to go to check out. And so the electrons can flow faster through that circuit because there's less resistance in the circuit because there's more places for them to flow. So there's the equation if you're curious. So basically you still do the same thing. You're adding the resistances, but all of them are 1 over. So they're a fraction of the resistance. And then you take the fraction of it. So insanely small resistance compared to a series circuit. So the thing with a parallel circuit, as more resistances are added, you get 3 major things happen, which are actually a good thing to a point. You get an increase in the current in the circuit. So as you add more items to the circuit, you get more current, right? Because of that grocery line kind of idea. the same voltage is maintained across each resistance. So there's no change in the voltage, and you get an increase in the current. And you get a lower total resistance in the current in the circuit. So it's basically the opposite of what we see in a series circuit. And the other big upside of a parallel circuit is you don't shut down the entire circuit if you get a break in it, right? The circuit still works. If one section breaks, the rest of the circuit can still run. So this is another section that's not in the text, but this is to show you how household and most, like business buildings, their circuits work. So they're actually a combination of series and parallel circuits. So if we take a look down here at the bottom, we actually have a series circuit here with the light. So you can see the switch. And this is all one circuit right here. But the switch is alone. And then the circuit supplies not just the light, but all of these outlets. So this is a series circuit because the switch is going to turn this one on and off. But it's not going to stop these guys from getting power, and they're all wired in parallel. So you can see they've got the different branches that it can flow. And here is our ground wire. So you can see there's the load wire, the one coming in from the power company. And then, like I said, there's that second wire. That's the ground wire or the neutral wire that is maintaining that potential difference. So, the lights and appliances are in parallel to each other. But the switch in the series only turns off the lights. So that is the part that is the series, like I mentioned, but the whole thing is in parallel. So what is the downside of a parallel? Because they sound great, but there is a downside to a parallel circuit, and that is when they can overload. So overloading happens when circuits carry a more than safe amount of current. And this can only really happen in a parallel circuit because they have that decrease in resistance, which increases the current, right? Series circuits, they can only increase the resistance. So parallel circuits, these guys can overload because as you add more and more loads onto a parallel circuit, it increases the current in the circuit. So you may have been told to not plug too many things into a circuit. This is why. So let's take a look at how this can happen. So our electric potential coming into your house is usually between 110 and 120 volts. And with each device, you get more current added. So you saw that, I'm sure. But let's take a look here. Our wires that are in the house are only rated to actually be able to deal with a certain amount of amperage, a certain amount of current. And so in this example right here, this wire is set to be able to handle 20 amps. So it can only handle 20 amps, 20 coulombs of electrons flowing through it. And so you can see they've plugged in a lamp, a heater, and a toaster. All of these together equal 20 amps. Now, if you plug in one more item, let's say another lamp, which will bring us to 22 amps, that's going to be more than this wire can handle. And what will that do? It will cause the wire to overheat because too many electrons are flowing through the wire. And that's what can lead to fires. That's one thing. We're going to look at another way that can happen, but that's the one way that you can get fires, is that those wires can overheat because you overload the circuit. So in the next video, we're going to take a look at things like safety fuses to see how we can keep circuits in parallel from overloading.